In this video, I'm going to talk to you about some of the things you want to think about when you are approaching these matching problems. In this packet, there are a few rounds. They're all labeled on the bottom of the page. So for round 1 and round 2, you're dealing with 3 function graphs. Anything with a number is the graph of an original function. The things with the letters are the derivative graphs, and we're trying to match which functions go with which derivatives. So for the first and the second round, you're matching up 3 functions with 3 derivatives. And as you go further through the packet, sometimes you'll have 6 functions and 6 derivatives, and you have to match them up. So it gets a little more challenging as you go. So what you'll want to do is try each round. I'll do round 1 with you, but then you want to try each round and check your answers against the answer key. When I look at these problems, I like to start by really focusing on the derivatives. One thing that I mentioned in class today is that anytime you see a break in the graph, like for graph A, we have a break right at x equals 0. For graph B, we have 2 breaks in the graph, or I should say jumps. And then for graph C, we also have a jump at x equals 0. So one thing to know is that any jump in the derivative, so these are all derivative graphs, so a jump in the f prime graph corresponds to a corner on the F graph. So with A and C, derivatives A and C, we have jumps at x equals 0. So we know that we're going to need a corner at x equals 0 for both of those. So we're probably already thinking about what graph B is going to be because B has 2 breaks in the graph. B has 2 jumps. So that means it's going to have 2 corners, and only one of the function graphs has 2 corners. So this one has 2 corners. Graph 3 is the only one with 2 corners, so graph 3 is going to have to go with derivative B. I'm going to mark that right on the top. But now we need to get a little bit more involved to differentiate between A and C with graphs 1 and 2. And I'm just going to So we need to do a little bit more to get A and C for the graphs. So what I'm going to look at next are the positive and negative regions of my derivatives. One thing that we talked about in class is if the derivative is negative, the original function must be decreasing, and if the derivative is positive, then the original graph must be increasing. If I look at graph A, so derivative A, this first section of the graph here, this first section of the graph is positive. It's above the x-axis, the graph is positive. If the derivative is positive, that means that the original function must be increasing. So what I'm going to do below this graph, I know that this is positive section of the derivative. That means that the original graph must be increasing. I'm going to draw myself a little increasing arrow. The next section of the graph, this section here, is negative. If it's a negative section of the derivative, the original function must have been decreasing. So notice we don't know how high or how low it is. I just know that I'm increasing and then I'm decreasing. This next section of the graph, we're above the axis again, so it's positive. We have another increasing section. This section of the graph has negative y values, so that would look like a decreasing section on the original curve. So we need to put these ideas together. We have increasing, decreasing, increasing, decreasing. And we know that we have a corner when x equals 0. So if we look at our two graphs, 1 and 2, for graph 1, this first section is increasing. I'm increasing. The next section is decreasing. I have my corner at x equals 0. I'm increasing, and then I'm decreasing. So this is going to line up with derivative graph A. I have increasing, decreasing, increasing, decreasing, just like I had on my derivative. I had positive, negative, positive, negative. Now let's double check with graph C. Let's make sure that C is going to go with function number 2. So let's just make sure. I'm going to give myself a little bit of space to work with. Okay. If I do the same sort of process, so I look at my derivative, I'm negative, my derivative starts out negative, which means the original function must have been decreasing. Then my derivative is positive, so my function must be increasing. My derivative is negative, my original function must be decreasing. And then my derivative is positive. And if we look at graph C is decreasing, and then increasing, and then decreasing. Oh, I forgot the corner. There's a corner at x equals 0, and then I'm increasing again. So these are some of the things you want to look for. Jumps in the derivative is always a really good thing to identify first. Sometimes, like for graph B, we were able to get that. Then you want to start looking at positive and negative intervals on the derivative because that's going to line up with increasing and decreasing sections on the graph. Now, if I walk through the positive, negative for derivative B and graph 3, just for the extra practice. So I start on the left side. This is a negative section of the derivative. Negative section of the derivative gives me a decreasing section on the function. I already see this first section here is decreasing, so I'm feeling good about it. I have a positive section on my derivative, positive section on my derivative, and I have an increasing section on the curve. I have a negative section on the derivative, and I have a decreasing section on the curve. And I have a positive section on the derivative with an increasing section of the curve. So it lines up pretty well. Let me toss in my arrows. Okay, so you want to try round 2. You want to check your answers against the answer key, and I will come up with more videos. If I have the time to make more videos for the other rounds, I will do those and post those. But if you're working on this before I have a chance to make those videos, the answer keys are already posted.